Good morning, dear students. I, Ashish Kumar Pathak, your science teacher. Welcome you all in our today's video lecture. I hope you have enjoyed our previous video lecture sessions. In case if you are finding anything difficult in those previous video lecture, you can make a call or you can send your questions on WhatsApp and clarify your doubts. Okay, so before moving forward, I want you all to take one copy as well as a pen with you so that you can note down the points which are told in this chapter, as well as you can note down the numericals which we are going to solve in this video lecture. Note down the formulas, how we are going to solve it, and later on you have to do some homework also. So be ready, be attentive while listening to the video lecture now. So I think all of you are set. So let's start the video lecture. Now before starting, I want you all to see this first slide which is in front of you. What you can observe in this slide is that there's burning something. Okay, some burning process is carried here where they are burning some wooden logs. Okay, so the chapter name is related to that process only. So you have to name that process. What is this? What all we get from this? Any guesses? What could be the name of the chapter? Okay, so I'll give you a hint so that you can identify the name of the chapter. So first I want you to answer this, that if you are burning something, what all things are required? What are the necessary material or conditions to carry out combustion? Okay, to burn something. Okay, you can note down that answer on that piece of paper which you are having. Okay, so the things which you require, if you have written, you can check. Things which you require to carry out combustion is, first thing which we require is fuel. Okay, it could be petrol, it could be diesel, it could be LPG, it could be the matchstick as well. Okay, you require some fuel to carry out combustion. The first thing is fuel. Second thing, you require combustible substance. Combustible substance is that which burns, okay, which catches fire. Okay, that combustible substance is required to burn something. It could be paper, it could be cloth, okay, it could be plastic, polythene. Okay, there are numbers of combustible substance present all around us. Third thing required is physical conditions, like it includes weather conditions, properties of material. Okay, there should be optimum temperature outside. Okay, if it is very cold, it will take time the things to burn, it will not catch fire easily. So the temperature must be the optimum temperature for combustion to take place. Okay, so three things we have recalled. That first thing is fossil fuel, second is combustible substance, and third is temperature or weather conditions, you can say, and fourth, the most important thing, that is oxygen. Okay, you require oxygen. There must be optimum adequate amount of oxygen must be there to carry out combustion. If there will be no oxygen, no combustion will take place. So the name of the chapter is combustion? No, the name of the chapter is not combustion. So what else? What else you can see from this picture is the flames are coming. So the name of the chapter is flames? No. So while you are burning something, you get two things. First, you get light. Okay, you're able to see the light is there, light coming out of it while you're burning something. There's one more thing which you get while burning is, which helps in cooking food. Okay, that is heat. Yeah. So our today's chapter name is heat. Okay, I hope you know about this word heat. You might have came across this word many a times. So today in detail we're going to study heat and the different things which are related to this topic, heat. Okay, let's start. Now first see what all topics to be covered. Now topics to be covered in this particular video lecture is, first thing we're going to see what is heat. We're going to have a basic idea what is heat. Okay, is it a thing or is it a name? What it is. Okay, what we call heat in science. Next, we're going to study about an important thing related to heat, that is temperature. Okay, what it is? Temperature. Okay, we're going to understand what is temperature, why we need to note it down. Okay, how we note down the temperature, what all are the basic units of temperature. Okay, and how to convert one unit to another. Like you weigh in country like India, you weigh anything. If you want to weigh your bag, okay, if you want to know your weight, you use unit kg. But in different countries, European countries, they use pound. Okay, pound as unit to find out the weight of any substance. Okay, like here you'll use kilometer as a distance, whereas in different European countries we use miles. Okay, so there are various units of temperature as well. Okay, in India, anyone knows which unit we use to measure temperature? Yes, we use degree Celsius or centigrade. Okay, you can call it degree Celsius or centigrade. Okay, so in detail I'm going to tell you about what is temperature, how we note it down, okay, which device we are going to use to find out the temperature, okay, and what all are the basic units in which temperature is represented. Okay, then next topic is measurement of temperature. Okay, how we going to measure it. Okay, can we measure it with weighing scale or with a scale? No, we're going to measure it with a special device. Okay, do you know the name of a device which we use to measure the temperature? Okay, when you fall sick, okay, you're suffering from some disease, you fall sick, you went to a doctor. So doctor first checks your body temperature. How he checks? Anyone? Yeah, the device which he uses, very small device. Nowadays they are digital device they are using. Earlier they used to be mercury filled. That device is called thermometer. So we're going to study about thermometer, how it works, the working principle. Okay, we're going to study about its construction, what all parts are there. Okay, next we're going to study about the liquid filled inside in it. Okay, that black liquid which you might have seen in thermometer if you observe it. So that thermometer liquid, why we fill that liquid only, why not we use water. Okay, next thing we're going to study how to take reading from thermometer, what is the correct way of taking the readings. Okay, then we're going to study about types of thermometer. So basically there are two types, that is clinical as well as laboratory. Okay, you might have seen clinical thermometer. Now clinical thermometers are also found today in two varieties. Okay, first one are that old one, traditional one, which are made up of glass. Okay, they are mercury filled inside. Nowadays we are using new one, electronic one, that are digital thermometers, which are not having this mercury filled, and they work on different principle that I'm going to tell you about how they work. Next we're going to study about laboratory thermometer. Okay, how it is different from clinical thermometer, what is the use, what is the basic difference between the construction of both. Okay, and next we're going to study the conversions of temperature from degree Celsius to Fahrenheit, Fahrenheit to Kelvin. Okay, that's all. So let's start. Now first thing what comes to our mind is, what is heat? Okay, is it a name of person, place, thing? Okay, what is heat? Now heat is basically, it is a form of energy. It is written there, heat is a form of energy. Okay. Now my first question is, can we create energy? Yeah, can we create energy? Some students will say, yes sir, why can't we? If we are rubbing our hands, we are creating heat. Yes, but energy, according to the universal law of conservation, energy can neither be created nor be destroyed. Means you cannot create energy as well as you cannot destroy it. What happens is, you transform one form of energy to another. So while you are rubbing your hands, okay, in winters you found your friends, they are they are shivering, so they start rubbing their hands. Okay, they start rubbing their palms, and it generates heat. So in that particular process, you are doing mechanical work. Okay, you are creating friction between your hands. As a result, this mechanical work converts into energy. That friction force which you are applying, that converts into energy, that is called heat. Okay, so here it is. Similarly, there are various methods to create heat. So there are various sources of heat. Okay, now in earlier times, okay, if you go back into your history, that early men, okay, they used to eat berries, fruits, okay, since they don't know how to burn it, how to cook food, so they used to eat raw meat, which is dangerous, which is harmful for your body. They're not able to digest it, okay, and it is not as well as tasty also. So they found out a way of creating heat, that is by striking those pieces of stones. Okay, they strike it, and they bring it near some combustible substance. It could be dry leaves, okay, and when they strike, it creates some spark, and dry leaves catches fire. So they're using friction between those two stones, and that mechanical work is converted into. So what I'm going to tell you here is that energy can neither be created, cannot be created. It is, and neither it can be destroyed. But what happens is it can transform, it can change from one form to another form. Okay, it can change from one form to another form. Now, so one homework which I want you to give, that you have to give me an example, okay, where you have to show me how one energy converted into another. So now second point, go to the second point. What it is written, it is measured in joules or calories. So heat is measured in joules or calories. Okay. So joule and calories are the units in which we measure heat. Like you measure your weight, measure volume in different units. Like you measure weight in kgs, measure volume in liter. Okay. So similarly, heat is measured in joules or calories. Okay. So I'll give you a simple example. You can see, okay, when you buy something, either you buy a food packet, it could be Lay's, it could be any stuff which you bought from market for eating. On the packet you will see any food item, either you took one biscuit or anything. You buy on the packet, you will see that it is written, it contains carbohydrates, that many calories are there, fat. Okay. So calories is what? When you eat food, either you're eating anything, you get energy. Okay, you get, if you are feeling cold, you drink hot tea, milk, or you eat something, you get energy. Okay, so you get heat, you get energy. So energy is measured in calories. Okay, it is measured in calories, kilocalories or joules. So we measure heat in joules. Now let's see the sources of heat. Okay, the various sources of heat. Some are natural, okay, which is provided by nature to us, and some are man-made. Man has made some devices which generates heat. Okay, like the first source of heat on screen is sun. Okay, you know about sun, you heard about it in the previous classes, what is sun, what all it does. Okay, so what is sun? What is the basic thing it does is it gives us heat and light. Okay, it gives us heat and light. Now it gives us heat and light. So how it generates heat? Okay, I told you earlier only that energy can neither be created nor be destroyed. So how come sun produces enormous amount of heat? Now it produced by proper reaction. Okay, it undergoes a reaction called nuclear fusion. Okay, in that particular reaction, hydrogen which is present in sun, okay, that converts into helium. So through that particular nuclear reaction, it creates energy, heat and light, which it transmits to different planets by the mode of heat transfer that we're going to study in our next video lecture, that is radiation. So sun is the most important natural source present on Earth. Okay, we are using solar energy in different ways. Okay, you can write it in a notebook what all are different ways of sun giving heat. Like we use solar energy to cook food. We use solar energy to generate electricity as well. Okay, so there are various ways nowadays. We are using solar panels to generate electricity through solar energy. We are using solar cookers to cook food. We are having solar water heaters. Okay, you might have found that solar water heaters are there, which use solar energy to warm up the water, which we can use. Okay, they are renewable sources of energy, so that we can save electricity. Okay. Now next thing which is there is fossil fuel. Okay, what is fossil fuel? You know the word fossil? What does it mean? Now fossil means any dead remains. Okay, dead remains, dead bodies. Okay, when any animal dies. Okay, when any animal die, what happens is that the dead bodies, the fleshy part is eaten by carnivores. Okay, they eat it, and the rotten meat, which is not eaten by animals, it is eaten by scavengers like vultures, eagles. Okay, they eat it. Now the dead bodies, it consists of bones. Okay, now these bones are decomposed by microorganisms. Okay, the small tiny organisms which you cannot see, present deep under the crust, they eat it. Now during this process, since there is less amount of oxygen present under the earth, they decompose. They keep on decomposing these bones, and these bones after millions of years turns into coal. Okay, which is fossil. The fuel which we obtain from dead remains of plants and animals is called fossil. So like in this picture you can see that coal is burned. Okay, so fossil fuels also generates heat. Like coal, you burn coal, it generates heat. Okay, we use coal, and earlier we used to use in that steam engines in railways. We burn the coal, it generates heat, which we use to boil water. It generates steam, and that steam helps in running that steam engine, and that's how train runs. So nowadays we are using electric vehicles. Okay, electric engines are in use in railways, but nowadays coal is used in power generation. You generate electricity through coal. Okay, they use that coal to burn. Okay, we burn it, we generate heat that boils water, and that turns into steam, and that device called turbine. It rotates and it generates electricity. So fossil fuels are also one of the sources of heat generation. Okay, the next homework is you have to write the names of fossil fuels which you know. Okay. Next is friction. Okay, I've told you about friction earlier, that early men used to discover fire through this only. When you strike two pieces of stones, it creates some spark, and things that leak catches fire. So friction also helps in generation of heat. While you're rubbing your hands, okay, you'll get heat. Okay. Similarly, when you are riding a bicycle fast and you apply some brakes, it generates heat. Okay. So friction creates heat. The next thing is electric induction torque. Okay, it is a modern method of producing heat, where we are using electric energy to produce heat. So here we are using electricity to produce heat to cook food. So these are some sources of heat. Now next is flow of heat. How the heat flows. Okay, you can check this at home. You can perform an activity. What you have to do is you have to take two things at a time. You have to take one hot body and one cold body. You can take a cup with hot tea or hot water. Okay, it's not necessary that you have to take tea only, hot water, hot liquid, and a bowl with water. Okay, it could be normal water, it could be cold water as well. Now, what you have to do, you have to place this cup into this bowl with cold water. Now wait for 5 to 10 minutes. You will observe that the liquid inside the tea becomes cooler. Okay, it becomes cold. It loses its heat. Whereas the water in the bowl becomes hot. Why it happens? It happens so because the heat from cup moves towards the bowl. Okay, it moves towards the bowl. So that's how heat flows. The heat always flows from hot body to cold body. It never flows from cold body to hot body. It always flows from hot body to cold body. Okay. And when they reach the same temperature, that heat flows stops. Heat flows stops. For example, you can perform one more activity. You can, for example, you are having hot milk at home in a vessel. You can keep it in your room. Keep it in your room and wait for some time. You'll observe that it will lose some heat. It will become somewhat cooler, but it will not cool that much that it is that much cool that you can not put your finger inside it. It will cool that much only as the room temperature. If the room temperature is about 38 degrees Celsius, the milk temperature also will be, that hot liquid temperature will be also like 37 or 38. It will not reach 0. Why? Because the heat flow stops at thermal equilibrium when both the bodies are at equal temperature. When both this cup and bowl are at equal temperature, the heat flows stops. So what we understood from this particular slide is the flow of heat starts from hot body to cold body and it stops at when the two bodies are at thermal equilibrium, means the temperature is same. Okay. Now, next thing what comes to our mind is temperature. Okay, what is temperature? If someone asks define temperature, the definition of temperature is it is defined as the degree of hotness or coldness of an object. How hot or how cold an object is, that is determined by temperature. Okay. So in the second point it is written, it is measured in Celsius, Fahrenheit and Kelvin. Okay. Celsius, Fahrenheit and Kelvin are the units which we use to measure the temperature. Okay. The third point says the SI unit of temperature is Kelvin. Okay. You might not have heard this. So the SI unit of temperature is Kelvin. Okay. The one question must strike your head is, so when these devices are not made, okay, when thermometer is not in the picture, are there also people with their hand they can judge that this thing is hot and this thing is cold? You can also judge it if your body is, or if you are suffering from fever, and if you put your hand on someone's body, you find it it's hot and it is cold. So why we are using this thermometer? So the basic reason why we are using a device called thermometer to measure the temperature is because it gives us the approximate value of our body's temperature. By hand you cannot judge that it is 38 degrees Celsius or 40 degrees Celsius. You require one specific device. Okay. So that device is called thermometer. Now, so I told you there are various units of measuring temperature. So the first unit which we have came across is degree Celsius or centigrade, Fahrenheit and Kelvin as well. Now you have to note it down, this formula in a notebook, so that you can memorize it and you can understand how to convert. So the formula is like degree Fahrenheit equal to bracket degree Celsius into 9 by 5 plus 32. So this is the formula for conversion of the temperature if it is given in degree Celsius to degree Fahrenheit. Now let's solve an example that if they are asking to convert 45 degrees Celsius to degree Fahrenheit, how are you going to do this? So you can do this by just putting the values into the formula. So I have solved one for you. You can go through it. That is 45 into 9 is 405. We divided by 5, we will get 81, and then we add 32 to it. Then we get 130 degree. So in case you are finding it difficult, you can ask. Okay. Now next is homework for you. You have to solve this and you have to send a pic of it. That sir, I have solved with steps. You can't write 30 degrees Celsius equal to that much Fahrenheit. You have to solve it like I have solved. So you have to give me that answer. Use this formula. Next, we are going to inverse it. Now we are going to convert degree Fahrenheit to degree Celsius. The formula is different now. The formula is degree Celsius equal to bracket degree Fahrenheit minus 32 bracket close into 5 by 9. Now let's solve an example. We have to convert 86 degree Fahrenheit to degree Celsius. How are we going to do this? We'll just have to substitute the value at 86 minus 32. After that, you have to multiply it by 5, the answer which you get, and then later on we'll divide it by 9, we'll get 30 degrees Celsius as answer. Okay, this is a very simple method. You just have to subtract it, and the answer which you get you have to multiply and divide by 9. Now the next one is homework for you. You have to convert 120 degree Fahrenheit to degree Celsius. In case any confusion still persists in your brain, please ask. Don't hesitate in asking questions. We are here for you. Now next is conversion of temperature in Kelvin to degree Celsius. Okay, I hope I'm at your pace. I'm not running fast. The formula is degree Celsius equal to Kelvin minus 273. Okay, you have to. Why sir this 273? Because 0 degree Celsius equal to 273 Kelvin. So here, an example, you have to convert 320 Kelvin to degree Celsius. How are we going to convert it? 320 minus 273. You just have to subtract it. No division multiplication is involved. It's very simple for you. That is 320 minus 273. You subtract it and get 46 degree Celsius. Simple. Okay. Now next one is homework for you. You have to convert it and you have to send a pic. Now next, inverse of it. Now you have to convert degree Celsius to Kelvin. Now what we're going to do is, we're going to add it. The formula changes. Now you have to convert degree Celsius to Kelvin, you have to add 273 to it. Now, example is there. Convert 40 degrees Celsius to Kelvin. So, you have to add 40 plus 273, that is 330 Kelvin. Very simple. Next one is homework for you. That is convert 60 degrees Celsius to Kelvin. Now let's study about thermometer. I hope you have gone through these numericals well. Now, try to practice as many as possible so that you excel at it. Now, thermometer. So the question comes, why we need to use thermometer, why we can't use hand. The first basic reason is you cannot get exact temperature. You cannot tell that exact temperature is this much of any substance. Second thing is you cannot touch everything. For example, if you want to test the temperature of any chemical, there you cannot dip your finger into it and you can test so this temperature is that much. Okay, you can just touch some body which is not harmful, like you can touch someone's head, someone's body. You cannot touch any metal object if that is burning and you can touch and tell that this. So we use thermometer to identify temperature, find out the temperature of different devices, different things which could be harmful for us. Okay. So it is a device used to measure the temperature of a substance. The thermometers are of two types. That is, we have two types: clinical and laboratory thermometer, I told. Okay. Nowadays, clinical art comes in two varieties. First one, the traditional ones, conventional ones that are made up of glass tube and they are filled with mercury. Okay. In some cases, you find alcohol also red color liquid. Okay. Nowadays, we are using digital thermometer. Okay, you find it that the digital way there. You just have to press that button and you get the temperature what all it is. Okay, easy to use. Now, next is laboratory thermometer is entirely different. Okay. Okay, now thermometer works on the principle that solids expands on heating. What it means? It means if you heat something, for example, if you're having metal rod, if you heat it, it will expand. It will expand. Okay, you might have seen some people are making screwdrivers. How they made? By heating it, they heat it until it reaches red hot, and then they start hammering, so that it will expand. Okay. So there's a basic principle that solids expands on heating. On this principle, thermometer works. I'll tell you in detail how. The thermometer consists of, if you see a thermometer, it consists of capillary tube. I'll tell you what is capillary tube. Which is filled with mercury. Okay, mercury is a liquid, it's not a planet. That is different. Names is similar, names are there, but mercury is a metal. It's a metal. That is found in liquid state at room temperature. Okay, keep this thing in mind. Underline this thing if you're writing that it is found in liquid state. Okay. So mercury is the only metal which is found in liquid state at room temperature. Okay, like metals like gold, silver. At room temperature, you find that they are at solid condition. They are not liquid. Okay. Now, mercury is the only liquid that is found at room temperature. That's why it is used in thermometers. Okay. Because it is found in liquid state at room temperature. So these are the parts of thermometer. Now this is a glass bulb. Okay, that part there, it is called glass bulb. What it does is, it acts as a reservoir. Reservoir, you understand? Reservoir means it stores mercury. When it is not in use, the mercury is stored here. Look at the black liquid which is there, that is called mercury. Symbol for mercury is Hg, capital H, small g. Okay, it is called hydroresidue. Why? Because it is called, in other terms, it is called liquid silver. It is called liquid silver because it is grayish in color. Next is lower fixed point. This is the fixed point where the reading starts. That is 0. This whole region till upper fixed point is called stem. These markings are there. This is called expansion wall, where that when the mercury reaches the highest temperature, it expands there. Then this is a hook for hanging. These are the parts. And this particular, thin glass tube, you can see that is called capillary tube. Okay, in which the mercury flows. Okay, I hope you have gone through all the parts. Now, in detail, I'll tell you about it. Parts of thermometer. The thermometer consists of a bulb. Okay, as I told, at the front, a small thin capillary tube, and expansion chamber. The bulb of thermometer acts as a reservoir to store mercury. Okay, it stores mercury. Whereas the capillary is a thin glass tube which helps in maintaining the flow of mercury in thermometer. It helps in maintaining the flow of mercury in the thermometer so that it can flow properly. Next is the expansion chamber. Okay, in that band I told that expansion chamber is there. It stores the mercury when the thermometer reaches the highest temperature of that range. Okay, so that range is there, limited range temperature it can reach. Now working out thermometer, how it works. A thermometer has a glass tube sealed at both ends. Okay, it is sealed from both the sides. You cannot open it and you can fill mercury. It is manufactured at special factories. There it is manufactured, so it is sealed at both ends and filled with liquid like mercury or alcohol. As the temperature around the thermometer's bulb heats up, okay, when you bring that bulb in front of a hot substance, it could be a human body, it could be a metal object, it could be any chemical, put that into it. Now what happens is that reservoir, bulb I said no, that it is a reservoir, it has mercury filled inside it. So that it rises up because I've told you that working principle that solids expands on heating. So as well as liquids. So the liquid rise in glass tube, it will rise in that thin tube that is called capillary. When it comes in contact with that hot substance. Now next is when it is hot, the liquid inside thermometer will expand and rise in the tube. So when it brings near to any hot substance, it will rise. The opposite will happen when it is cool. If the temperature of a substance is very cold, it will fall down. It will go downwards. It will not rise upwards. Okay. The temperature of a thermometer is read by keeping the thermometer at parallel level to your eyes and recording them. You cannot bend your neck downwards and you can note down the temperature. The correct way of measuring the temperature is you have to keep the thermometer at your eye level, parallel, so that you can get the correct reading. Otherwise, you will misjudge it and note down the wrong readings. And second thing, you have to take readings frequently. Okay? After 5-10 minutes, if you repeat it, you'll get the average. This is the correct temperature. The basic unit which is used in India is degree Celsius. Now the liquids which are used in thermometer. The liquids used in thermometer are as follows. First one is alcohol. Alcohol is also used. And second is mercury. The alcohol thermometer is also used to measure the temperature. It is often colored red or green because they add some color to it, pigment to it, so that it is easily visible to us. Okay. Since it is colorless, it is transparent, you cannot visualize properly what's the correct reading. It is difficult for you to note down the reading, so you color it. Whether they color it to red or green so that the person can easily see. However, alcohol is not used as a liquid for high temperature because it boils at 80 degrees Celsius. So alcohol is not used for high temperature measurement. So its boiling point is low. It boils at 80 degrees Celsius. So in that case, we use mercury as liquid in thermometer. For measuring high temperature, we use mercury as liquid in thermometer. We use mercury because its boiling point is high. Okay. Now next is clinical thermometer. The clinical thermometer, as the name suggests, it is used to measure human body temperature. It is used to measure human body temperature. It ranges from 35 to 42 degrees Celsius. It ranges from 35 to 42 degrees Celsius. Okay. It consists of a kink. Okay. Noted down, it is not king, it is kink. K-I-N-K. Okay. What is kink? I'll tell you in detail. Let's see this diagram. Look at this bent part, you can see. This bend is done purposely. Okay. What purpose it has? That this kink, it opposes the reverse flow of mercury. Okay. It opposes the reverse flow of mercury. Okay. The thermometer is filled with mercury which expands on coming in contact with hot or cold substance. Okay, I will give you a real life example by which you can understand why we are using kink. Okay. So we are using kink. For example, if you are measuring body temperature of some person, and as soon as you remove it from his armpit, the mercury level will start to fall down because it will fall according to the room's temperature. So to reduce the speed of reverse flow of mercury, we are using kink so that it can stop the reverse flow of mercury as possible. Okay. So that's why we are using kink, a bent curve. Okay. So this is capillary tube. Now the human body temperature in Celsius is 37 degrees Celsius, 36.9 degrees Celsius, whereas in Fahrenheit it is 98.6 precisely. Okay, that is a normal human body temperature. Okay. Now next is laboratory thermometer. How they are different? The laboratory thermometer is used to measure the temperature of chemicals. They are used to measure temperature of chemicals. Because they are not used to measure the temperature of human body. Used for measuring the temperature of chemicals. The range is different. In case of clinical thermometer, which we have covered in the previous slide, the range starts from 35. Okay, 35 degrees Celsius to 42 degrees Celsius. Whereas in case of laboratory thermometer, it starts from minus 10 degrees Celsius to 110 degrees Celsius. Okay. Next, it is filled with mercury to measure temperature in various liquids. So they are not using alcohol because chemicals are generally found at high temperature. They possess high temperature, so we purposely use mercury. It doesn't have kink. Why it doesn't have kink? It doesn't have kink because these thermometers are plugged into a thermometer holder. Okay, they are having some thermometer holder or rubber stoppers in which they are placed vertically. Okay, so that the reverse flow is not possible only. That's why they are not using kink. Okay, we can see this covered thermometer is not kink. There is no narrow constriction there. So this is bulb, mercury filled, capillary tube. I have already explained this thin glass tube. These are markings. Okay, it starts from minus 10 to 110 and this all sections. Okay, nowadays we are using digital. Why we are using digital thermometers? The reason is very simple. In case if you are not handling these glass-made laboratory or clinical thermometer properly, then the mercury which is filled inside will come in contact with the environment, it will mix in with air. And if you inhale it in a large amount, it may suffer from some respiratory problems. That's why. And it is not easy to decompose it. Okay, if it is not showing correct reading and if you want to destroy it, it is not easily destroyable. So that's why we are using that digital thermometer. So there you are not using this mercury. There they are using bimetallic strips. Okay. It works on different principles. Okay, thank you students. I hope you enjoyed this session. Okay. Start working on it. Note down the points which I have covered, like what is heat. Heat is measured in SI units is joule and it is measured in joule. It is also measured in calories. What is heat? It is a form of energy. Then we've gone through sources of heat. Okay. There we have covered different sources, natural as well as artificial. Okay. Next, we've gone through temperature. What is temperature? That is degree of hotness or coldness of an object. Okay. How the heat flow starts, from where it starts, where it stops, how it stops, when it stops at thermal equilibrium. What is thermal equilibrium? When that both the objects, hot and cold, are at same temperature, then the heat flow stops. Then we go through device called thermometer. Okay. What all parts of thermometer we have gone through? That is bulb, kink, capillary tube, stem, expansion, expansion valve. That all is there. Then we go on to different units. We solve some numericals. We convert degrees Celsius to Kelvin, Kelvin to degrees Celsius, Fahrenheit to degrees Celsius, and degrees Celsius to Fahrenheit. Okay. And then we have understood digital thermometers, why we are using nowadays, laboratory thermometer, their range, clinical thermometer. I hope you have enjoyed this session. In case if you are still confused in any part of the topic, you can directly send me a WhatsApp and help you out in resolving your issues. Okay. Thank you very much.